In lesson 20, we're going to continue to look at transformations and we're going to focus on stretches. So let's look at this particular example. We have the parent function that is x squared and it has been translated 5 units to the left and 3 units up. What is the formula for the function g depicted by the translated graph? So let's see. I know that if it's moving left or right, that whatever change that is has to happen before the x gets squared. So I'm going to include that inside the parentheses. And because it's going left, I'm going to have a plus 5. And then I know that if it's moving up or down, that has to happen after the square. So that would be plus 3. And that is pretty much the formula. You should be able to know that by now. And then from here, we can get the vertex if we wanted to graph it is the opposite of that number. And here you have it if you need it graphed. This particular one does not have x-intercepts because my vertex is going to be above the x-axis. So we have 3 parabolas here in this exercise. And what I'd like for you to do is pause the video and try to figure out how these g of h and h of h, how do they change from the parent function, which is x squared? Go ahead and pause the video and try it. Give it your best. So the first thing that I would probably do that you may have done already is set up a table of values. It's important for you to set up a table of values for your x squared, your parent function, and then your new function so that you can tell how the points have changed and you can start looking for patterns. And because these are situations where your vertex, your minimum or maximum is the same, 0, 0, we know that this is not shifted up or down, left or right. So we know that we are dealing with some sort of stretching or shrinking. So that's why it's important to set up a table of values. And that's actually what I'm doing right now. I'm just looking for some points that I can find that are not half points or quarter points that I can use to do that comparison. And what I'm actually going to do is I'm going to, in a minute here, set up a double T table. And so my red values are going to represent values coming from the parent function. And my purple values are going to come from my new function, in this case, g of x. So I have 2 x values that I can use to compare when x equals 4 and when x equals 8. What is y? So for my parent function, y would be 16 when x equals 4 and 64 when x equals 8. But for the g function, I notice that when x equals 4, y is 1, and when x equals 8, y is 4. And so when I start comparing these two, what I'm noticing is that there is a big change. So what could be happening is that before I actually square the x, it could be that I am dividing that x by something. And so I start thinking about, well, what could that something be? And what I come up with is, well, if I divide each of these by 4, then when I square it, the quotient is going to give me the exact y value. And that's sort of the game that you have to play. You have to look for the pattern to determine what the scale factor would be. And so 4 divided by 4 is 1, 1 squared would be 1, etc., right? So I determined that the formula, where'd everything go? Oh, let me write it real quick. The formula for g of x is going to be 1/4 x to the power of 2. Now, what I'm doing now is I'm doing the exact same thing for h of x. And don't worry, I'm going to put the formula in a minute here for g of x. I know you can't see it. So for h of x, I'm actually picking 2 different x values because I couldn't find, the big ones just wouldn't work for this. There's 2 things that I immediately noticed. One is that there's a reflection on the x-axis, so I know I'm going to have a negative coefficient. And the second thing that I'm noticing is that these numbers are actually being larger than my original, so they're being multiplied by a scale factor that's greater than 1. So whatever this type of stretch is, it is going to be multiplying this x value by some sort of scale factor that's greater than 1. So let me see. If I multiply these y values by 2, then I would get my result. 4 times 2 is 8, and 1 times 2 is 2. So this is what we call a vertical stretch, whereas the other one, g of x, is a horizontal stretch. I'm going to write the formula right now. It's 1/4 x to the power of 2, and the other one is negative 2x to the power of 2. So the main difference that you see between these two stretches are that the scale factors are in completely different places. So for h of x, I'm multiplying the y, and so it happens after you square the x value, and that's why we call that a vertical stretch. It happens outside the parentheses, and the g of x happens inside the parentheses, so before you square it, and that's because the x value is changing, not the y. And so that is sort of the main difference and an easy way to remember these two.